Hello friends, welcome to online school. Now in the previous video we've looked at how to differentiate product, how to derive quotient rule, and then let's show you to see how to use quotient rule. And so remember that we have u as a function of x and then v as a function of x, but then they are forming a quotient, or u is being divided by v. And so now let's try to look at an example. Assuming that we have our function y, and then y is equal to 3x plus 2, this being divided by 3x plus 1. We're going to find that now this is a function of x, and then this one is also a function of x, but then they are forming a quotient. So in this case here, remember you have our general form as y equal to u over v, like that. And then so we want to find the dy dx, but then we have that dy dx is equal to v du dx minus u dv dx over v squared. And then so you take note that it is supposed to be v du dx minus u dv dx. Once you interchange these two terms, then it will give you something wrong. So we have v du dx minus u dv dx over v squared. And then so this is how we are going to label this. So we can say that this numerator is going to be our u, and then this denominator is going to be our v, like that. So now after getting to that, we get the du dx and then the dv dx, and then we substitute into our formula. So we shall have our u being equal to 3x plus 2, and then our du dx from this we shall have 3x. When you differentiate 3x, this is an explicit function. So when you differentiate this 3x here, you will remain with 3, and then when you differentiate these 2, it will give us a 0. So du dx is going to be 3, and then we have our v as 2x plus 1. So the dv dx is going to equal to this 2x here. It will give us a 1. This is a constant. It will give us a 0. And after getting that, we can substitute that into our formula. Then we shall be having dy dx being equal to v, which is 2x plus 1. Then du dx, which is a 3, minus u, which is 3x plus 2. dv dx, which is a 2. The whole of this expression here divided through by v squared, and then our v squared, we just get a v, which is 2x plus 1, and this one here squared, right, like that. And then so you can simplify this, and then on simplifying we shall remain with dy dx being equal to this 3 can multiply this to get 6x plus 3 minus 6x plus is minus 6x minus 4, right, like that. The whole of this being divided by 2x plus 1 squared. So make sure that you don't forget this squared here. People make mistake at this point here, they forget this squared here. So then after that we have 6x minus 6x, so we shall remain with dy dx equal to negative 1. This 3 minus 4, this will cancel with that, negative 1 over x plus 1 squared. And then so by so doing, or by reaching this step, we have reached on the derivative function of our given function y equal to 3x plus 2 over 2x plus 1. And then so note that now so far we've not looked at chain rule. Let's first look at chain rule, and then we shall have more examples or the trial questions on how to use quotient rule and product rule. Why? Because most functions, when you're differentiating them, or most forms of functions, when you're differentiating them, you'll have to use product rule. I mean, you have to use chain rule. Take an example of a function like y equal to x squared plus 2, and then this one being to power 4. So such brackets, you need to differentiate them using chain rule, because this one here, it's a function of a function. So let's first look at that, and then later on we shall have prior questions from product rule and quotient rule. So now you happen to note that the numbers we've been trying out, they never needed, or there was no need of using chain rule in differentiating them. They are just simple explicit functions. And so let's first have a look at chain rule. Then after that, we can get trial questions from product and quotient rule.